Thank you for coming to my session. My name is Tahsin Dane. You can find me on Google Plus and Twitter with these names, and I usually tweet and post Google Plus in English, so you can easily follow me. So I will talk about material design and how to apply material design to your custom views, actually in views in general. I will first talk about what is custom views, what do we have in the platform to use in our layouts, and then why it is not enough and what we can do about it. And some tips and tricks to make your life easier, hopefully. Android views, when you begin Android development, first thing you should see is actually Android views. There are what do we have in the Android SDK? We have text views, images, buttons, of course, and some view groups to place them in. We have linear layout that places the views linearly, horizontally or vertically. We have relative layout that we can relatively position the children views. We have a couple of else as well, and then we have great view setup. Actually, I am not going to talk about it, but if you are curious, you can search for it, and it is actually great for performance. So these, we have already these, but can't we have great applications, great designs with only using these? Let's see. Actually, we cannot. Let's talk about what Android views are responsible, and let's see how we can customize them. They are responsible for attaching and detaching to the activities, and they, of course, measure themselves. View groups also measure their children. They, of course, drove to the screen. They also save their state, imagine if you have a text field, edit text, you write something into it, and when you rotate the screen or go back to home and come back later, you will have the already entered states saved, right? So they also, of course, handle touch events. For example, buttons have click listeners, and time to time you may have gestures like swiping from the left to right, and they are all handled by the views themselves. So why do we need custom views? The first thing, and actually for me, the most important thing is the view reviews. Like most of the Android developers, I hate code duplication, and custom views gives us the ability to avoid code duplication. Right? We can, when the platform views are not enough, we can have unique representations in our UI. We will see a little bit more about it. We can have custom interactions. We can have also optimizations, because imagine a relative view, for example. It is designed to have to handle all the relative positions of the children, all the possibilities of all the developers can do with it. So when you look at the when you look at the codes of these platform views, they are huge. For example, the view class itself is the base class of all the views and the view groups. It is like 10,000 lines of the code, which is actually really a bad practice. And when you use the built-in view groups as well, they are really good for simple applications, but when you have a really big hierarchy in your application, it may affect the performance. So actually, layout optimizations is also really related to performance, and you can improve the performance of your application just by having custom views. And of course, you can customize your views to have not possible UIs with the built-in platform components. So I will give an example of a custom view and talk about how to keep it consistent with the material design and the new devices. Let's see. So imagine we have a social application where we have profiles, and in every post and in every comment we may have comments. In every comment we will have like a profile picture and name besides it. So we will probably have this UI for different people in the application one more time, right? Normally, when we do this in a naive way, we will probably have something like this in our layouts. We will have a linear layout with horizontal orientation, and gravity will be center. This can be modified a little bit, but this is just an example. We will have an image view and text view next to it to have the profile name. And we have a margin between image and the name. So let's see. And in the code, we will probably find the name view and the profile image by using find view by ID. And set the text and image of the views using these lines. We will probably have a user object, user class, and user class will have a name property and an icon property. So when we have more than one profile pictures like this, it is a really bad practice to just copy and paste this. Like imagine a Facebook application and there may be hundreds of comments inside a post, and you may not want to copy and paste this 100 times, right? So what is our option? What is the best way to handle this? You may of course use a custom view. We will see how we are going to do it. First, we create a class and extend a linear layout. In this example, since I already have a linear layout, I extend from linear layout, but I can extend from anything in the platform. And you must have constructors when you have custom views. The Android Studio actually forces you to have constructors. The first constructor you should have is the default constructor. Oops. Default constructor with the context. This is used when you inflate your view programmatically inside your Java code. And these constructors are never, mostly not used programmatically by the Java code. These are used by the system when the views are inflated using the XML layouts. So, and then within the constructors, we may have, within the custom view, we may of course have the text view and icon view, and we will have a user, right? We will inflate the view inside our linear layout, and we will get our text view and icon view with using find view by ID again. And when we set user, we will automatically set the text and the images of the view. So we have also a slight difference and optimization in this layout. So in the inflate function, in generally, when you put here a view group, it inflates it and automatically puts the view inside this. So this will inflate this layout and automatically puts all the views inside this into this linear layout. So let's see how we modified the profile view. So this was the old linear layout I have been showing. So we already have linear layout as our class, right? We extend from linear layout. So if we have linear layout here as well, it will be a duplication and will be bad for performance as well. Instead, we will use merge tag. So this merge tag is really great, and it helps you to flatten your hierarchy in your views. What it does is that when you inflate this, it just put these children inside your view group as if you wrote it inside it. So it will not add a hierarchy in your activity. It will be better for the performance as well. So if you are including views into another views, consider using the merge tag. So another thing we can do is we can imagine you have the profile view. You will do the same thing when user clicks it, right? You will always open the user profile activity when it is clicked. So it is also a really bad practice to copy and paste the set OnClickListener method everywhere. So we can have set OnClickListener in the constructor here, and the profile view can implement OnClickListener itself, and then it can handle the OnClick event itself. And all the activities that are using this profile view won't need to write this code over and over. It will just pass the user and open the profile activity here. So the other thing I mentioned was the SaveState. You saw that we have a user object inside our view, right? So let's see how we can save that user on configuration changes. So normally Android platform saves scroll position, selections in the lists, also user input in edit text, for example. They are all automatically saved, but it cannot save our user object, right? Because it is custom. So what we should do is that just like activities save state functions, we have on save instance state here. It is a little bit different from the activity. You should return a parcelable here. You can create your own parcelable, or you can use bundle here. You will just put the user into that bundle and then get the user back here. So this saves the user and this restores the user. Okay, so we had a really simple example of custom views. So when you use system components, you will have nice ripple animations, for example, in Lollipop, selection states, everything. But when you do something custom, you will use the nice things you will get from the system. Like the system components handles all the things perfectly. So we need to, material design is so hot, and we of course want to make materialize our UIs. So when we have custom views like that, what should we do to keep the good things from material design? So I will, actually there is really more to it, but I will speak about how to apply material design a little bit, and then how to keep ripple effects and using widget tinting, palette library, and theming support. And I will talk about how to keep these backward compatible wave up to API level 7. So let's see. So before material design and the new Appcompat library, it was really hard to theme your application in the whole world. It was really hard. But after material design, not just material design, it was not just about the view. It was in the Android world. It also make our lives really easier to theme our applications. And later, they didn't release Appcompat completely after they just released material design, but Appcompat is really helpful right now. It improved a lot. We will see how you can use it. So basically, this is the basic application theme you will use. The parent should be from theme.appcompat, and then the rest you can decide. Here I have the light theme, and the action bar will be dark. And then I will provide primary dark colors and the accent color of my application. And I should open my activities, and I should extend from Appcompat activity. When you create a new application inside Android Studio, this comes by default actually. But for your old applications, you have to do this, and you have to use you have to parent from Appcompat themes when you use Appcompat activity. Otherwise, it will crash. So when you do this really simple step, your application will be materialized mostly even on the lower API level devices up to SDK level 7. So what it does actually, when it sees the platform components like text view, button, edit text, it tricks the inflator and converts those views to material design alternatives. Like this. When you have a button in your layout, it actually converts it to Appcompat button. and so on and so forth. But when you have custom views that you extend from a normal button, you should now extend from Appcompat button. This is also a public component in the Appcompat library that you can use. So you should extend from these instead of normal button, checkbox, etc. in your custom views to be materialized, because otherwise it will use the old style buttons, because it doesn't know anything about your custom views. So the other nice thing they introduced was the ripple effect. So when you change the background of your view, when you have something custom, you probably lose this. So actually before the recent versions of the Appcompat library, when they first announced material design, it was also really hard to keep this and be compatible with the older versions of the Android. So they have now really nice attributes that you can use. When you use selectable item background attribute or selectable item background borderless attribute, you will get the nice touch effect on devices after Lollipop with a ripple effect, and you will get the nice touch feedback on the older devices as well. The difference between these can be shown here. As you can see in these buttons, in the animation, the ripple effect goes beyond the button like a circle. So this can be done easily with this attribute. And when you have complicated views like linear layout or frame layout, you can cover your complicated view with a custom background, with a frame layout, and you can have foreground tag inside your frame layout. So recently in Marshmallow, actually, foreground is available in most of the in all the view groups in Marshmallow, but they haven't backward compatible. They haven't done this backward compatible yet, so you cannot use it in the devices below Marshmallow. So you basically need to cover your views with a frame layout and have foreground with selectable item background. Yeah. So the other nice thing is that you can use the Android version of the platform version of the selectable item background. But what is different with this Appcompat version is that it fixes the old devices too. So for example, in the Hello World before KitKat, all the default touch feedbacks were blue. Even if your application's color is different, the users with old devices will see blue touch feedback, which may not be compatible with your color scheme. So when you use this, it will automatically be gray. If you can see this gray area in the slides, it will automatically make the blue to gray in all the devices. So the other thing is widget theming, which I like the most. It helps a lot with daily development of my life. So it is actually again introduced with Lollipop, but it was not backward compatible with the last two versions of the Appcompat. They also make this backward compatible. So I will talk about it more, what it is, and I think it's amazing. So we have this, right? But we may want to have this the same layout on a dark background. What you will do normally before? You will set the background manually, and you will change the text color manually, right? So not anymore. Actually, imagine we have a profile view. We are using like this in XML. You can now set the theme inside your widget. You can change the theme of your widget anywhere you want. So by default, if you don't write light here, the theme.appcompat is actually dark. So it will automatically convert this to this with one line of code, one line of XML. So let's see. These actually may not be seen in the presentation, but I think for users it creates a huge difference. So normally when you have something like this, when user clicks, he will see a ripple and then selected state like this. Can it be seen easily? Okay. So this may not be seen easily. So imagine you converted the background yourself manually. What happens is that, can you see the difference? No, because I can see in my laptop, but the difference is really not obvious and cannot be seen on the device as well. Because the touch feedback is designed for the light background, it is so light that cannot be seen on a dark background. So this happens when you do it manually. So there is no difference in these images. So when you add that one line of code, can you see this? The difference? Yeah, it can be seen. Like when you add that just one line of theme code and don't do it manually, you will get the nice ripple effect as well. And you can see the color difference here. Historically, this was also really hard to do before material design. You would have lots of code just to do it. You would have custom background code for dark backgrounds and light backgrounds separately, and you would have to apply them separately. But now you can just change the theme inside a part of the layout, which is great. So let's briefly look at the other attributes. I talked a lot about the selectable item background because I think that is the most important thing in the library. But we have others like action bar size attribute, list preferred, item height. So if you can look at here, it has Android tag, right? So why is there a difference between these? It is because text color primary attribute is there from the beginning of the Android. So all the devices already have this attribute. This is really old because it is basic. So actually Appcompat automatically also changes this to make it material. But what about the new APIs? For example, this is introduced in API level 11. I think this is introduced in API level 17 or 16, I think. So the attributes that are introduced after API level 7 are now all available in the Appcompat library. Before, you would have to detect that if the API level is above 17 and you would use the platform version of this in API level 17 and you will do something else in the old devices, but not anymore. Almost all the attributes are now in the Appcompat library. So how would you find if which one is available in the Appcompat and which one is not available in the Appcompat? There is actually not a good way to detect it. You will just delete the Android tag here and see if it compiles. Yeah, if it compiles, you may want to use the Appcompat version because it will be available until API level 7. Yeah, that's the only way. Let's see. So, the last couple of things. Actually, I have more slides. Let's see. So there are also in Appcompat library quick utility functions that you can use. For example, to access your primary color attribute inside your theme, you will have to write like 6 or 7 lines of code previously. But now, if you use theme utils, you can just get the color in 1 line of code. And there are a couple of changes in Lollipop devices. The accessing to the colors may affected by the theme, which is not available in the old devices. So this is the right way to access your drawable and the color, actually. Don't use the normal get color function. You will better use ContextCompat to access them in your Java code. So the other thing is widget tinting. Widget tinting is like you may have an image. You can easily change its color to red, which is great. You don't have to supply the same image, same assets in your drawable folders with different types of colors. You can just wrap your drawable and apply a tint color. The one downside of this, it has to be done programmatically. You cannot just apply this within XML. This is one of the downsides, but yeah. And we also have palette library, which is introduced with material design at Lollipop, and it is also available in the Appcompat library, and it supports API level 7 as well. It is great to extract colors from images, like it extracts blue here and pink here, which you can use in all the devices. So I will pass the details of it, and thank you. By the way, this is the link to the presentation, bit.ly/material-design DFUA. And once again, you can find me on social media using these.
Okay, guys, so what about questions? Please raise your hand and I will go to you. Okay.
Hi. At the start of the presentation, you show us how it works, the ripple effect. You set a background to the button. Yep. Selectable other. But how do you set the green color to this button? Because you already use the background.
Yeah, you mean how to make the selection, the ripple effects like green or in any
yes,
color?
Okay. How we can set
Yeah.
the color of this theme.
So the question is how can we change the selection state color and the ripple effect color? So it is actually discouraged to change its color. So because gray is looks good on top of every color, if you want to change its color, actually you will go really custom. So you will have and if you want to keep the ripples, of course, you will have a drawable separately for API level above 21 with ripple effects, with custom color, and you will have another drawable with that color alone for old devices. You cannot do it with one line of code.
But as I understood, we set the background attribute to the button. So how we can change the main color of the button, not on the ripple effect?
Yeah, good question. Again, so the question is if we change the background normal, not press state background color of the button, how would we keep the ripple effect with using selectable item background? You would have to wrap your button with a frame layout and use foreground attribute of the frame layout. So if you can go back to it. Let's see. Yeah, this. So your button should be here with any background color you want, and you have to wrap your button with a frame layout and set the foreground color.
Okay, thank you.
Okay, any other questions? Yes, I see.
Thank you for speech.
Thank you.
Send me please. You showed the way how to set color tint for drawable that you set programmatically, yeah?
Yeah.
How we can do this for XML file, for example, some picture? Because sometimes you need like have some spice, like I don't know, figure that really hard to programmatically set. And I want to change the color of this drawable to different. Simply, but different.
So the question is, what are the other options
for XML?
For widget tinting, other than programmatically doing it? So there is no direct way to do it, actually. So there are two options that are easier than this. One is not released yet, but Butterknife. I think most of the people are already using Jake Burton's library Butterknife. In the upcoming version of the Butterknife, they will have one line of code to have widget tinting. You will just write there tint and then give the color, that's all. And the other option is to use the data binding. You know, data binding is a really powerful library. So with data binding, actually you can bind your Java code and the XML code. So you will have this Java code in any place, in a place in your Java code, but you can just bind it to your XML. So your XML code will automatically call this and will have a tint color.
Thank you.
Yeah.